You guys ready? Cool. Welcome today to the, I think we're officially the MLOps Utah meetup. I think that's our name ever since I joined the MLOps community, the big one. I don't know. I joined it. I joined them so that they, I don't know. We are the Utah chapter of the MLOps community. So that's good. This is our October meetup. Do we have any announcements? Not any.
West was great.
Go West was amazing last week. We didn't have any ML talks, but
I don't know who set that up, but they did a great job.
But whoever set up that conference is amazing. That was me, by the way. Good news is Joe Reese has invited me to start helping him with the Utah Data Engineering Meetup. Yay. So now we're going to get UDEM announcements at the ML Meetup and vice versa, because I'm now in charge of both of them. So I'm in charge of all of Utah Data Meetup. So yay me. We tentatively have a meetup scheduled for next month. I may be moving that to January, so we'll see. The speaker doesn't want to speak anymore. But hopefully we'll keep our meetups going. We've been doing good. We have some really good. We want to thank MX again for always sponsoring. MX is great. If you haven't joined the Forge Utah Slack, talk to me. I can get you on that. They have a great job board. I know a lot of people aren't hiring, but they continue to post new jobs every day there. So somebody is hiring amidst the chaos. So our speaker tonight is Daniel Whitenack. He is a friend of mine. I met him when I took his machine learning in Go workshop in 2018, I believe. I think it was 2018, so it's been a minute. And then the next year, I bugged him long enough on Slack to let me assist him in the 2019 meetup. So I helped him give a meetup by my consistent nagging, which I'm really good at. He works at SIL International. He does some great NLP on lots of rare languages, and he has a great podcast that you should all, if you do not listen to, it's Practical AI, right? That's the name of your podcast?
That's correct, yep.
It's a great podcast. Great machine learning podcast. I just realized you can only see my backside because I'm talking to people.
All good.
But yeah, I'll go ahead and turn the time over to you, and we're all super excited to hear about all your fun NLP stuff you got to share with us today.
Cool, sounds good. Let me see if I can present successfully.
Present, share screen.
Let me see. Screen, which one is screen 1 and which one is screen 2? Hopefully I can find the right one. I'll try screen 2.
Yeah, I got slides.
Okay, cool. Awesome. Well, thank you for having me. Great to be called your friend, and great to get connected a little bit more with this community. Excited to speak to you about supporting natural language processing, or NLP, in 7,000 plus languages. Hopefully that will make more sense as far as what I'm talking about as I go along here. The goal of this presentation is sort of to give you an idea of I think a wider view of AI and language generally, and sort of how our vision and our work at SIL fits into that. But then talking about, like, okay, we're talking about NLP in 7,000 plus languages. Where do we even start with that? and what do we do as part of some of our work. And I thought since this is MLOps meetup, I would just pull up some of our infrastructure and show you a few things and let you all tell us what we're doing wrong so you can help fix our problems. Or hopefully learn something from what we're doing. And yeah, have some time for discussion and questions along the way. So as was mentioned, I'm David Whitenack. I'm a data scientist with SIL International. Talk a little bit more about that here in a second. I also co-host this podcast, Practical AI, with one of the AI strategists at Lockheed Martin. So if you're interested in podcast stuff, you can check that out. It's pretty fun. The conversations that we've had there. This is a few of the people that I work with on our team at SIL. So for those of you who don't know, and probably most of you who don't know because SIL sort of flies under the radar to some degree, we're a global nonprofit. So we work on our sort of vision overall to see people flourishing in community with the languages they value most. And we do language-related work in over 100 countries, I think. We've got like 1,600 or more projects going on around the world. We've got like 4,000 staff working in all parts of the world and sort of from all parts of the world. This, though, is a smaller group of people who I lead at SIL who are working on natural language processing and AI. You can see some of the names here and us standing around a box with GPUs in it. So that's kind of the team that is doing a lot of the work that I'll mention as we go along. So let me talk a little bit about AI and language more generally, and sort of how that fits within our vision of what we're doing at SIL. If I kind of bring up, and you all are a more savvy audience than I would normally talk to, but normally if I'm talking to an audience about AI and language, people sort of have in their mind something like this. So like a voice interface. In the West, in our context, a lot of people might view this as sort of like a novelty. People use voice interfaces maybe more in other regions of the world, but you might think of this, but actually sort of AI and how it's influencing how we use and flourish with our languages is actually kind of embedded much deeper. And I think most of you in this audience probably realize that. So of course we've got machine translation. Maybe that's something that comes to mind as well. But as you all probably know, there's even things as like fundamental to how we operate online, like Google search, that is being driven now by large language models, not by the sort of pure PageRank algorithm that it was always driven by. And so, Google search, in your Gmail or whatever, you see autocomplete, but even places you might not like always expect to see AI showing up, like in education. We've got this company is just one that I pulled up that uses some type of, and everyone says they're using AI now, but I think this company is using AI to somehow help people learn things. And so you've got sort of AI and language impacting education and like the basic ways that we flourish online with our languages in Google search and email, in chatbots, in like spam filters, and in all of these ways where like to truly flourish online now with your language, you are needing to have your language supported by AI systems. The reality, though, is if we kind of bring this down to the local language situation around the world, if we look, and I just pulled these numbers from kind of one of the online cloud providers that provides AI services. So if we look at things like sentiment analysis, syntax analysis, named entity recognition, text-to-speech, translation, machine translation, automatic speech recognition, and we look at the number of languages supported by these systems, again, this is kind of one of the major cloud providers. what we have is like maybe at the most for these basic functionalities which support things like I just showed, we have support for maybe like a little bit over 100 languages. So around the top 100 languages of the world. But for some things like text to speech, for example, you might have support for like 30 languages, something like that. And not to diminish the work that has gone on, and it's been really great work to increase the language support for these types of systems. However, if we compare that to the total languages in the world, which right now is around 7,100 something languages spoken in the world, basically it's negligible the amount of languages that we support in the major sort of AI tasks that we would think of in terms of language support, like machine translation or speech recognition. Even if we combine like all of the cloud providers together, we might get to like around 200 something languages of support. But again, compared to the 7,000 languages spoken in the world, that's a drop in the bucket. So this is a representation of those 7,000 languages spoken in the world today. That also includes like maybe languages that you don't think about that often, like 400 sign languages spoken across the world or signed across the world. And if we look at, other people that are probably more reputable than myself, like the creator of Keras here, we can see this is just a quote I think I pulled from Francois' Twitter about, one of his greatest worries kind of being this lack of pre-trained models for other languages other than English or maybe Mandarin, which is really cutting off these languages and cultures from the next generation of AI applications. Here's another quote from Jeff Adams. He leads Cobalt Speech, speech and language, and he was on the team that kind of created Alexa at Amazon, talking about the challenge that it is to support languages, the world's languages in speech technology. So despite what like Eric Schmidt at Google might say on Twitter, speech and language is not a solved problem. There's actually a lot of languages that don't fit into the technology that we're building. And so this is really where SIL kind of wants to dig in. Again, our vision is to see people flourishing in community using the languages that they value most. And the reality is that you can't flourish in the digital sphere any longer without your language being supported in AI and NLP systems. And so what we want to do is work to make sure that the benefits of AI and NLP extend to those local language communities, and that more NLP solutions are linguistically diverse, rather than sort of the propagation of AI and NLP technologies cutting off languages from being, supported and being further marginalized as they try to engage in the digital sphere. So that's all the context of like the area in which we work. I lead this team at SIL that's really digging into trying to understand how do people want to interact with their languages online in the digital sphere? What are the barriers and the challenges to making that happen? And how do we extend NLP technologies to local language communities? So that's all great. That's a nice sort of pitch as far as like, okay, that's a great social good problem that we can dig into, supporting more of the world's languages in our NLP systems. But if we look at that gap, right? So from like around 100 languages supported in general in things like machine translation, speech recognition, to 7,000 languages supported in those systems, how do we even know, like as a team, like, if my team is tasked at SIL to like dig into that problem and start to support more languages in these types of systems, where do we even start with that? And so that's where we've actually taken a bit of a data-driven approach to understand like where we should start digging in and what's the most optimized way to go from the situation of 100 languages supported in systems to 7,000. And the idea is that, hey, why don't we start strategically and target certain languages that are sort of primed or are hotspots for AI and NLP work. And so here I'm going to show a few pictures to describe how practically we think about some of the work that we're trying to do. So if we map out all the languages of the world, so imagine all of these languages are, there's a circle for each language of the world. Obviously, there's more than 6 languages. There's 7,000. But SIL actually has all the languages of the world mapped out. There's a product called the Ethnologue, which we support, which actually has data about every single one of the 7,000 something languages of the world, where they're spoken, what their vitality is, all of the characteristics of the language, where it's spoken, all of that stuff. So thanks to that work that's gone on for quite some time, we do have all of the languages of the world mapped out. And so the idea that we've come up with in terms of our thinking on our team and how we attack this problem is to think about the fact that a language where AI and NLP techniques can be applied immediately with the most benefit is a language where maybe NLP isn't supported yet, but that language is closely related to a language which has high, what we would call digital language support. Meaning that, like, okay, a language with high digital language support is maybe already supported in machine translation, already supported in speech recognition. There's public data sets available for it. There's, language models, there's tokenizers, there's all of these things associated with that language. And if there's a language that's closely related to one of those sort of thriving digital support languages, we can actually learn a lot from that highly supported language as we move into the next language that's related. And so what we've done, this is work from Gary Simons, who's our Chief Research Officer at SIL, and was just published actually last month or this month or whenever it was at Coling 2022. He and his team actually mapped out, so they scraped the internet for every single language of the world. They figured out how that language was supported in terms of available data, in terms of technology, in terms of available services. And so up at the top right, you've kind of got languages that are supported in like assistants like Alexa and all of that sort of stuff. And over at the bottom left, you've got languages that maybe they don't have any data associated with them or a very small amount of data, but they're not supported in any NLP systems. They're not supported in products and services. And so you go from this sort of emerging or still support of digital language support all the way up to thriving digital language support. And so what we've done in our sort of strategy is look at languages of the world, and then we pick out, okay, well, certain of those languages are thriving or vital in digital language support. And that's great. Those languages are already flourishing in the digital sphere to one degree or another. But we can go a step farther and then see, okay, well, there's languages that are related to those languages that are thriving that are not yet supported in the digital sphere, are not yet thriving in terms of support. But as you all probably know, taking something from, a pre-trained model in a language where there's high digital language support and fine-tuning it for a language that's related is something that really modern NLP is built on. So the idea here is that we piggyback off of these thriving or vital languages and start to build in support for this next level of languages and then kind of move down the chain as we go along. An additional kind of analysis that we've done here is to use work from Carnegie Mellon University. They did work, if you just look up Lang-to-Vec, sort of like Word-to-Vec, but Lang-to-Vec, they actually mapped out learned embeddings for all languages where you can sort of, how you can do like a word embedding and compare one word with another word and see how close they are and how similar they are. They've done the same thing essentially for languages, where they've mapped out the characteristics of syntax and phonology for languages and determined which languages are related to one another with those features. And so we've actually further ranked the languages of the world based on just how related these languages are to languages that have thriving or vital digital language support. And so what we get coming out of that is like a cluster like this, where for all of these languages I'm showing on the screen, they're all highly related to either Bahasa Indonesian or Malay, which are themselves closely related languages. And so if I look at one of these languages like Jakun here, which is only spoken by 5,000 people in the world, which is a pretty small language, what I can figure out is that Jakun is actually very, very related, like more than 90% related phonologically or syntactically to Indonesian and Malay. Meaning, if I was to fine-tune models for Jakun off of Indonesian and Malay models, I could actually have a lot of success. So if I tried to support something like speech recognition in Jakun, I would actually do much better than some random pick of a language around the world, because I can piggyback on what's already been done for Indonesian and Malay. So this is just to give a sense of the strategy that we're employing, and the fact that we're putting a lot of thought into how we approach NLP for the world's languages, rather than just kind of picking and choosing. And of course, SIL having so many people working around the world, we have local connections into these communities. And so we're also leveraging those local connections to spin up work in these different languages. Okay, so let me describe a little bit about what we do, what we've been doing specifically. I'm going to do a bit of show and tell, and then I'm going to show a few things about infrastructure, because I know this is like MLOps, and you guys, that's really all you care about. So I'll show you a bit of that and what we're doing in that respect. So what do we do? It really comes back to this quote from Francois. A lot of what we're thinking about is these sort of foundation or base or pre-trained models in all of these languages of the world. And so if I just kind of go out here and I go to Hugging Face, which I know someone in the audience loves Hugging Face, at least because they have a shirt. I can go to Hugging Face here and go to some model like BERT based on case, right? And this is a language model which I can use as a foundation or base model to train various downstream tasks for things like classification or sentiment analysis or even machine translation and other things. The fact is, though, that there's not a lot of linguistic diversity in these foundation models. There are some, so if I go here and I scroll down, I will see some Chinese models and other models, and even some multilingual models that support like 5 languages or 100 languages or whatever it is. But really, one of the blockers in advancing NLP is the fact that I don't have linguistic diversity representing the world's languages in these foundation models. And so one of the approaches that we've taken is doing some creative things to train new language models. So this is an example where we recently did some work in multimodal language models. If you start working in small languages at all, what you'll realize is that, let's say I think about that language Jakun in Indonesia, and I look at what data is available for that language if I want to train a language model. Well, likely what data is available for that is a whole mix of things. There might be some Word files, there might be some CSVs, there might be some PDFs, there might be some audio files, there might be some videos. It's going to be a whole disparate set of things. And so it's really critical when we're working with local language models and local language data to be able to use multiple modes of data when I'm doing my training. And so we've done some work in partnership with the University of Dayton to train multimodal language models that can take text or audio as input. And the way that we've done that is by taking either text or the audio and doing a transformation on either one of those to where for text, we transliterate it to phonemes, which is basically a representation of sounds. So there's models that will allow you to take text and put it into phonemes or an international phonetic alphabet. And then we can do the same thing with audio using a tool like Allosaurus from Carnegie Mellon. So we can take both of these forms of input data and actually transform it into phones. And then we can train a model for a language model or a foundation model or base model in the phonetic space rather than in the space of characters, like Latin characters. And we've shown that we can do that for, here's an example of what those phones look like on the right-hand side. We can actually do tasks like named entity recognition and other tasks in this phonetic space. And so that's one thing that we've explored is the sort of multimodal nature of language models and how that operates, how we can uniquely train models when we have a small amount of data, but that data is mixed between different modalities. So that's one thing that that we've explored. The other question is, well, where does this data come from in local languages to even feed into a model like this? One of the products that SIL supports is this Bloom Library product. If you just go to bloomlibrary.org, you'll find this. And this is a product that we support, which hosts, or it allows local language communities to create books and content in their languages. So you can see we've got around 12,500 books across 530 languages. In this Bloom library, and you can see some of the languages here. So if I click on this language, I can see there's all sorts of different books in a whole variety of categories, including science and literacy and education, entertainment, all sorts of categories. So one of the other things that we've done as a team, in addition to exploring kind of unique language model or base model architectures like this, is to actually take existing data sets that are out there and include a lot of linguistic diversity and actually pre-process and prepare those for AI tasks. So this Bloom library existed when I joined SIL, but it had never, like the data out of this had never been processed into a format that we could use it for NLP tasks. And so something we've done recently, and I can show a picture of how some of this data looks. We've taken the data out of these books, and you can see how that data looks. It's sort of on each page of the book, and actually, let me, I can just pull up a book here. We'll go to one of these books. I don't know, about lions. I don't know what this is about. But you can see there's sort of one interesting thing about these books is a lot of them have images paired with text. And a lot of them are also actually talking books. So there's audio, there's people speaking the language, and it's paired with the text. And so we've actually extracted all of that and we've formatted the text and the audio like this in the form of albums and in the form of like arrays of text across different languages, which is super interesting for tasks like, I mean, it's super popular now to do like text to image and image to text tasks. We all love stable diffusion and that sort of thing. So this forms kind of the seed of data in a lot of different languages for those types of tasks. But also, if you pair the audio along with this, provides kind of bootstrap data for tasks like speech recognition or text-to-speech sorts of tasks. So we actually just had this work accepted to EMNLP, so we'll be presenting that in December. And we started to already release, if you go to our SIL International organization on Hugging Face, you'll start to see us release things over the coming weeks. For example, there's a Bloom LM data set. So this is, I think, across 363 languages. There's data of various sizes across those languages. And you can download that for language modeling tasks. We also have, here's Bloom Speech, which is that audio side of the data sets. So we've got 56 languages right now where we've released, and most of these being small languages that are not supported in like speech recognition systems. We've released audio across those languages. And then there's a few others that we'll release soon. We've also started releasing models associated with these languages. So here's a bunch of wave-to-vec models that we've trained for speech recognition across these languages. This is a language Bisu in Southeast Asia. It's only spoken by about 700 people, I think, in the world. But based on the data that we've had available in Bloom Speech, we've been able to train a wave-to-vec model on this language, which actually shows quite good results. So a word error rate of only around 8% on our test set. So that's really encouraging that this strategy of looking at what data is available and also pivoting off of large language models. So these wave-to-vec models are fine-tuned off of a larger wave-to-vec model. That's really paying off as we go along. And you'll see us start to release other things on here as we go along. So if you're looking for data across a whole bunch of languages, this is a good place to look. Just because you all are, you all seem like a nice group. Here's everything private that I have in GitHub as well. This VoxGRN data set, which is blank right now, is a data set that we're working with, which has about 12 terabytes of data across 6,000 language varieties. So as far as I know, this is the most linguistically diverse speech data set in the world. It's currently private, and we're working on thinking about how to do some releases around that as well. So part of our strategy, I guess if I was to summarize, is to look at the sort of how we do language models or train foundation or base models and enable new downstream tasks in linguistically diverse scenarios. Part of it is curation of data. And in this case, what I've shown is curation of existing data that we haven't released yet. But we're also gathering a whole variety of data as well. So that's a brief picture of some of the things that we're doing. We're doing a lot of other things too, and happy if you have questions about any sort of NLP task and how it's supported in local languages, and if we're doing anything there, I'm happy to ask or happy to answer those questions. But before I sort of finish up, I did want to just briefly talk about the sort of MLOps and infrastructure side of what we're doing, because this is a technical crowd, and I know you all are interested in that. Obviously, as I've already shown, we have we're heavy users of Hugging Face, and in terms of where we're versioning our models, some of our data sets, and how we're integrating that into our model trainings. A lot of that is happening here on Hugging Face. So this Bloom captioning data set, for example, is a data set for image captioning. If you look at the sort of files here, what we're doing is there's the repo, which contains the Hugging Face data set. The data set is living in our S3, and whenever we do a captioning training, we're pulling the data set using the Hugging Faces data sets library, similar to what's shown here, and performing a training of one kind or another. So in terms of how we're pulling data into trainings and how we're storing our models and our data, we're doing that directly on Hugging Face, pretty much mostly across the board. In terms of the data side that isn't just pre-processing and curation, but is actual data gathering, we're users of Label Studio. So I don't know if any of you have done this sort of thing, but we've done a number of projects with organizations like Masakane, which is a AI group working in Africa. And here's an example of, I don't know if I can share my audio on this thing, but I guess you'll just have to believe me. So this is text-to-speech models that we trained across 6 African languages, and we had actually members of native speakers of those languages come into this system and help us label all that data for these 6 languages. The nice thing about Label Studio, which I really like, is if I go here to this project, the labeling interface that I set up for this, so this is a sample audio where I think they were just setting up or they were evaluating the generated audio and rating that. But I can actually go in here and just create a like an HTML or XML type config for this labeling interface. And so all of this is completely customizable. A lot of what I've seen in other labeling systems is you kind of have presets for certain labeling tasks, which is great if you're doing those labeling tasks. But if you want to do something slightly different, then it doesn't work that great. So for this other labeling task, let me just see one of the alignment ones here. We had a custom interface, which included a bunch of different like radio buttons that were customized for that. And so all of this configures that labeling interface, and this syncs up right with our S3. So the data from this labeling interface goes back to S3. That's synced up back to S3. We can then pull in that data from S3, process it into Hugging Face data sets, and then pull it into our training runs. Speaking of training runs, in terms of MLOps proper, we use ClearML. The reason, so we actually evaluated a few different systems. I really like weights and biases as well. But in terms of this side of things of experiment tracking, or in terms of experiment tracking, I would say similar things are supported across ClearML and weights and biases. But one nice thing about ClearML, which maybe weights and biases has added since I evaluated it, is here we actually have this idea of workers and queues. So the reality of our team being that we are a highly distributed team around the globe. We've got people in Thailand and people in Europe and people in the US and people in Latin America, and they're all running different experiments. We've got some on-prem GPUs in Dallas. So we've got 4 A100s in Dallas. We've also got a couple workstations in different places of the world with different GPUs. And then we use cloud GPUs and cloud instances as flex capacity. And so what happens is, okay, so now we've got all of these disparate systems. We've got all of these people around the world that need to queue up jobs and queue up experiments on these systems. And what ClearML allows you to do is basically join workers from wherever they are. So that could be in the cloud, that could be on-prem, but you run an agent on that worker that points to and authenticates to this centralized dashboard or this central web server API. And that registers those as a worker in your MLOps system, and then you can set up a whole variety of queues. So you can see all of our GPU queues here right now that are up. And we've got one training going on that's training on the default queue. But these queues now will allow you to go in, and it's sort of like high performance computing in that there's like a job queue and you can submit jobs to the job queue. It's a little bit different though in that it's a pretty simple queue. It's just like you submit things and the first things that come in get executed. But for us, that works really well. So I can go in here to my projects, and let's say I had mentioned the captioning project. So here's some captioning baselines. Here's the previous experiments that I've run across different languages. And so I could go in here to one of my experiments. I can clone that experiment, which was captioning in a certain language. We'll call this MLOps Utah clone. And now I've got a draft of this experiment. I can change the container that that experiment is running in. So the Docker container that that's running in. I can change the dependencies, the installed packages there. So I could, like, let's say I go in here and I want to run this on Python 3.8.10 as my Docker container. My output, I can change the S3 bucket that my artifacts are going to be stored in. But I can also go in here and change like certain artifacts or configuration, that sort of thing. And then I can go here and enqueue it on, let's say I want to enqueue this on, let's enqueue it on my 40 gigabyte A100 queue. Okay, so you can see that's going to be pending now. And I probably messed it up in changing all sorts of different things with it. But you can see that's running. And now, so what's happening is that the web server saved all that metadata associated with the previous job. I changed up the configuration and then I re-enqueued it on the queue. And the centralized web server then sent a request to the agent that's running on the server in Dallas and has the GPUs in it to spin up this job. So it's spinning up the container and running the job on that instance in the container that I specified. And I can monitor the usage and all of that. They do have the idea of like pipelines here. So you can run like DAG pipelines in this. We've found that to be a little bit, so we're still getting used to that and how to do that. We've also run pipelines. If any of you have run across the Pachyderm system, we also do some data pipelining on Kubernetes and AWS with Pachyderm. But this is our main sort of MLOps system. Just to give you an idea here, I drew this sort of architecture thing, which I know is, you know, maybe not the most exciting thing to show in a presentation, but figure this is an MLOps meetup. So we do have a Kubernetes cluster in AWS and EKS where we run applications. We also run Pachyderm there to do some pipelining. We have the label studio for our data labeling that's synced up with S3. And we have kind of a data plane with our Postgres instance. We do have this server in Dallas, like I mentioned, which is connected to our MLOps, and MLOps is also connected to, like, we can log sort of ad hoc jobs that we're running in AWS notebooks or as AWS SageMaker training jobs to that MLOps system. So that's kind of the main pieces of what we're doing here as far as the infrastructure side of things. Hopefully that gives you a sense of who we are and what we're doing and some of the problems that we're working on. I think I've talked a lot. I don't know how long typically these talks go, but I'd love to hear from any of you what questions you have, either about like what's going on in the NLP world, what questions you have about our specific NLP work, what questions you have about local languages, or any of the random infrastructure stuff that I showed, or model stuff that I showed. Really do appreciate the opportunity, and yeah, looking forward to questions. Please, if you have any follow-up questions, reach out to me anytime, and you can find me online in various places. So yeah, any questions as we
Just at the. I'll hand you the mic as far as the cord goes. Yeah, just hold the mic and sorry.
No, that's fine. So my question is about turn of phrases. As you know, those are statements that you can't take literally. For example, in English, if you say out of the blue, you can't translate that into other languages. So how does your model deal with turn of phrases in different languages? Because each language has its own set of turns of phrases.
Yeah, metaphors are metaphors, turns of phrases, idioms. These are very difficult problems. I would say that the approach that we're taking in general is very much, in almost all cases, a human in the loop sort of scenario, or maybe what you would consider an active learning scenario. So in particular, where we're working on machine translation systems, what we have is not just a machine translation system that you give me your text and I give you text in a different language. What we have is three kind of pillars of that system. We have the machine translation system, we have a quality estimation system, and then we have humans. And so what happens is we set up an active learning scenario where you give me your input. Maybe you give me 30,000 samples to translate, right? And what I do then is machine translate those. But then before I give you the output, I run them through my quality estimation system. And I can talk a little bit about that if you want. But this system, basically, if you look up quality estimation as an NLP task, you can learn a lot about it. But what we're doing is we're trying to estimate the confidence that we have in the particular translations that we're doing. And for the really confident ones, like let's say I'm 99% confident that this one sample that I translated is pretty good, maybe I just pass that along through the system. But for the ones where I'm not confident, I prioritize those for human review. And by doing this sort of thing, you get kind of the best of both worlds. Like honestly, I don't need humans to review everything. But it's equally true that I can't get a computer to do everything. In particular, like this case that you've brought up, metaphors or idioms and other things are really difficult. And so if I'm able to assess the confidence of what I'm doing, then I can set up this sort of active learning type of scenario. And of course, once I get the human to review it, that provides me more data to retrain my models as well.
This is Chris with the Hugging Face shirt.
Hey, yeah, so I have tons and tons of questions, but I think I've got it down to two. So the first question I have, I want you to talk more about your CTS system. Is that Kokui AI, or are you guys using Tacotron or something older?
Yeah, great question. So what we've done recently, let me bring up. So one of our most recent projects is this project where we used. So if you're not aware, if you're looking for data in small languages, oftentimes the Bible is some of the only data that you have. And a lot of Bibles have audio Bibles associated with them. And so in this project, what we did is we looked at 6 languages in sub-Saharan Africa, and we said, can we train a text-to-speech model using audio Bible data? If so, can we use it both in domain and out of domain? Meaning, like, could we generate speech for like news data in addition to generating speech for like Bible data? And as it turns out, what happens is Bible audio is often recorded in really high quality, and it has a high sampling rate. There's not a lot of background noise. It's recorded at like 48 kilohertz. So it's actually like really, really good data for a speech synthesis model. It's also generally like single speaker. So what we did in this case was we used Koki, which, as you mentioned, is kind of they're doing amazing stuff in the sort of open source speech technology world. And we used that particular system to train models. And if you just search for this Bible TTS, you can hear some of the samples. But as it turns out, the samples both in domain and out of domain sound really, really good. So yeah, Koki is really amazing. In fact, they just released I think it's called Voice Studio, where you can like tweak and tune your synthetic voices even after training. So yeah, definitely something to look at.
Yeah, okay, that answers that question. That's really good. The second question I have is about the intuition behind why you guys are using phonemes as opposed to like orthographical lines that we draw generally in like college level English, or even morphological lines. You know, morphology could be another way to go. So why did you guys center around the phonemes in this case?
Yeah, it's a really good question. So just for people that don't know, there's sort of a few different things that we could choose. Like phonemes represent generally sound. So if you search for like IPA phonemes, you can see like these they're actually characters. Let's see if I can. So they're characters, but they represent sounds. They don't represent like language in the sort of way that characters do. So these correspond to sounds. Morphemes are like the sort of subunits of a language. So if you think about like, I have words, a word could be made up like let's say that I talked here tonight. A root of that is sort of talk, right? And the ed is kind of added on to indicate past tense. And so there's a lot, like a talk might be a morpheme, which is combined with other morphemes to make up words. And then the orthography of a language is basically how it's written. The interesting thing is that like sometimes your orthography, let's say the Latin characters of our language, represent how things sound. That's most often the case. However, in many cases, for many languages around the world, that's not always true. So not all orthographies represent sound in the same way that we do, which sort of makes kind of various things complicated. In terms of orthography and like why we chose, in the case of the language models we were working with, to use phonemes is, if you think about audio, in order to convert audio to orthography or writing, you basically have to have a language model already existing for that language, because you have to know what the language is represented in characters, right? But the whole premise of what we're doing here is that we don't already have a language model for this language. What we have is sort of audio, and we have some text samples. So that was the reason we didn't use orthography. In terms of morphemes, most of the languages we're working with don't actually have morphological analyzers that allow us to extract morphemes from text. And so that's why we centered on phones, because there's the technology to convert audio to phones, or audio to represented sounds, and to convert text to phones is actually, if you use tools like Epitran and Allosaurus, they cover the most languages, like more than 1,000 languages. So we get a huge bang for our buck if we work in this phoneme space. The disadvantage is people don't usually put pauses between their words when they talk. Like, it would be weird, really weird for me to talk like this, right? And so what you'd get when you get phones, a phone recognition out of audio, is you lose spaces. And so essentially you have to you sacrifice spaces and word segmentation to work in phone space. But for certain NLP tasks, that does work. So, yeah, great questions.
Oh, go ahead. Oh, you.
So I have a question that's a bit more meta, not as specific, but I'm not sure how big SIL is or how big the engineering team is dedicated to these projects, but for 7,000 languages, 7,000 plus, that seems like a boil the ocean kind of problem. So wondering like how you guys prioritize what you're going to work on, what projects are meaningful, and then how you stay focused with like such a mountain of a problem before you.
Yeah, great question. It definitely is a big it is a big task. So I would say a couple things. One of the things is that we do try to prioritize like specific clusterings of languages, like this cluster that I showed for Indonesian and Malay, where any work that we do in any one of these languages benefits all the other languages because all of them are so related, right? And so anything that we do in any of these languages is going to pay off for the whole cluster. And so thinking at a cluster level rather than at an individual language level is very useful because any of the tokenization things that I do for any one of these languages or any of the sort of grammatical rule things or any of the parsing things or any of the sort of corpus things that I do for any of these languages is going to benefit all of them, and I can kind of reuse a lot of things. And so that unlocks things for many languages at once rather than thinking about one language at a time, which I think is like partially why systems like Google Translate or something, I mean, they've done a great job at adding languages in recent years, but it's not advancing rapidly, right, in terms of going from 130 languages to 7,000. So thinking about it more at the cluster level, I think helps. The other thing that we think about a lot is both multilingual models and multimodal models. So how can we leverage all of the data available regardless of modality, but then also how can we train multilingual models? So it's true. One example that I can give is just today we were working on some quality estimation for a language in Mexico called Zapotec. And Zapotec is one of those languages that is not supported at all in NLP systems at all. But what we did was we reused, there's a model from Google called LabC, which is actually a multilingual model trained in 109 languages. And actually, that model worked out of the box, zero shot for Zapotec, at least for the task that we were using it for. And the reason for that is because there's so much knowledge encoded across those 109 languages that extending to the 110th language, zero shot, wasn't too far of a stretch. So the more we can build in linguistic diversity into foundation or base models, the more it becomes easier to jump to that next and that next and that next language, either by applying it zero shot or by applying it in a sort of transfer learning or fine tuning approach. So there's a lot of trickery and really great progress that can be made in multilingualism and in transfer learning. I should also say, I guess a third element of that, which is maybe more meta, like you were talking about, is partnership. So SIL is a bunch of places around the world, but we cannot accomplish all of this task. So I had mentioned we'd work with University of Dayton, but we also work with sort of grassroots organizations like Masakane. I recommend you look them up as a great example of this. Let me just pull up Masakane. So Masakane is a grassroots community of AI researchers across Africa. And you can kind of see all of the language or all of the countries that are represented in this community. And they're doing an amazing work in NLP across the continent of Africa. And so partnering where we can with organizations like this who are already doing data curation or already doing model training and assisting them to bring in things like our labeling system or our MLOps system and kind of unblocking them in certain areas where we can and letting them do part of the work is part of our strategy as well, because ultimately they have the on the ground knowledge anyway. They're better suited to do this than a bunch of Western people sitting in the US. We've got a partnership. We've got to partner with people on the ground and really have people that speak these languages lead the way as well.
Oh, sorry. Just a question. When you've got like multiple linguistic models, like if, for example, you have Indonesian and Malay and Jacun, and that's related to another language, like how do you go about kind of merging those models, or do you just take the embeddings and share them between them, or what does that look like?
Yeah, good question. So there's you could actually do both. So one approach, which is what is generally referred to as a quote multilingual model, is a model where the embeddings are learned cross-lingually. So your training set actually includes samples from all of these different languages, sometimes with a special token at the beginning, like with the language identifier or something like that. And the model actually learns an embedding that works across these languages, such that like a word embedding is cross-lingual, meaning like the place in the embedding space where like cat is located is similar to where like gato is located in another language, right? So you've got this shared, it's kind of like an alignment of the multilingual or multidimensional embedding space. So that's one approach. The other approach is to do sort of to leverage relatedness in the transfer learned or fine-tuned method. So we've done that actually a lot with Arabic languages. So there's a lot of data available for modern standard Arabic, like millions and millions of samples, right? So we can train a model in modern standard Arabic, and then for a Arabic vernacular in one of the Middle East or North Africa countries, we could actually transfer learn using a small set of data from that Arabic vernacular for the downstream task, using the parent model that was for the highly related kind of standard Arabic language. So we use both of those approaches depending on the task, I guess.
Thanks.
Go ahead. Yeah, you still got him for a couple more minutes.
Hi. So the end goal. So when you have like 7,000 languages in one base model, what's the relationship with like every nth language you add and the size of the model? Like, are there efficiency gains with languages, or how does that work realistically with deployment and on edge devices and things like that?
Yeah. So I would say the best success that we've had is working with this cluster approach. So rather than thinking of like sort of one model to rule them all, which probably would mean that like your parameter space for that model becomes really big, it becomes harder to deploy. What we've found to be a better solution, also because as you mentioned, edge is actually a really important piece for us because a lot of the language communities that we serve work in areas where there's not stable internet, which means that a lot of the models, like if we deploy it in a mobile device or we deploy it, on a desktop application or something like that, there's literally going to be someone like rowing a canoe up to a village and like they're not going to have internet and they need to be able to use this model, right? So model size and efficiency is a big thing for us. So we've found it much better to use smaller parameter size models and focus those on these clusters. So like Indonesian Malay cluster or like Arabic cluster or Chinese or whatever it is, and build it's sort of like a balance between the one multilingual model to rule them all, like the Big Bloom model that came out recently, and like a single language model which is going to be limited in terms of how it can generalize and how robust it is across languages. We're sort of somewhere in the middle most of the times, where we're working with a smaller language cluster like this, and try to bring down our model size to something that's reasonable, and then also pair that with tools like Apache TVM, or something like that to optimize model for deployment, or optimize models for deployment on edge devices. We've also used TF Lite quite a bit in the past to do this sort of thing. And we've got one system. I don't have a picture up right now, but it's an edge speech system. And what we do is we take audio in, so we stream audio in, then we detect what language is being spoken, and then we use a particular one of our language models to recognize the speech in that language. I think that the language identification model is like 90 megabytes on disk, like the model size, and the speech recognition models are like between 100 and 200 megabytes on disk. So these aren't like 3 gigabyte, 6 gigabyte models. We're trying to keep that size down, because in that case, we're deploying it on, a laptop or something in the field, or some comparable sort of compute device that might be disconnected from the internet.
Thanks.
Cool. Any other questions? Awesome. Well, we'll just give you thank you, Daniel. That was awesome. We got so, yeah. And we'll see well, that's the end of